Welcome, my name is Philipp Schwab and I will guide you through the webinar. I am very happy to present you our latest upgrade APOLLON 2023.1. The development of APOLLON is always moving forward and we have integrated additional functionalities that will make your work even faster and more efficient. We have focused especially on connectivity. We are excited about the new features and look forward to you trying this new APOLLON version. This upgrade will take your work to a next level. Then, have fun and thanks for watching.
Then we start directly in our current APOLLON version 2023.1 and we open a new assembly. So I have prepared a 3D facade sketch for the APOLLON construction here in the webinar, and we find this in our Kronos Explorer, so our new PDM software. So here we see the project structure, and we will open the prepared facade sketch. So of course you have different possibilities to create such 3D sketches. So of course directly in APOLLON, or you can create sketches in Athena Complete 2D, 3D and import this in APOLLON. Or of course also access models, files from cooperating companies or partners. So for example, directly from the architect or engineering offices. So we save directly here the assembly in the Kronos structure. So give them a name, facade, FFM Frankfurt, East End Gardens here for example, and save the file in our project. So now we're coming to our first big feature. So now it's a big benefit for you to use finished bar assemblies directly from your Logikal software. So we start the interface. The interface is now loading, and we have access to our enabled transom and mullion systems. So here I have my list and we use a Wikona system. So the class configuration is 32 millimeters and you can pick here the different profiles here directly in the dialog box of the Logikal interface. So I have prepared other bar assemblies, but here for the webinar we create 2 pieces of the used bar assemblies. So we have here the mullion, and now we import other transom profile. Here also the Wikona system, a transom and the class configuration of 32 millimeters. Now we add here in the dialog box again a desired profile, here a transom profile level 2, and we import this in our APOLLON construction. And you can see it goes very fast to add here the different components, yes, and import finished bar assemblies to assign these assemblies to your access model. Okay, we finished this step and we open a new part. Here we will open the Logikal profile library and we see here the different bar assemblies. So we have import 2 of this and I have prepared, of course, other profiles. Now we will customize the cutting contour of this a little bit fancy cover profile. So this is also a new feature. So you have the possibility to yes, to customize this special cutting outline to reach the special profiled cutting later. So you can pick here the different edges, click OK, and you have a new cutting outline here. So now we prepare the edges. Here 2 millimeters. And here on the left side 1 millimeter, and also on the right side 1 millimeter. So also this goes very fast, so to create individual cutting outlines on your bar assembly, and also with the visibility filter of the different outlines. So we would like to do this step again here on the mullion profile, and we would like to customize the cutting outline so to an outline as it's provided by the Vicona system. So with the APOLLON functionality, you can add here help contours. You see here on the right side in the ribbon bar the visibility filter, and we assign here dimensions 11.5 millimeters, and now we can pick here the edges, the profile contour, the help contour counterclockwise, and with a few clicks we can reach here our profiled cutting outline to do later in the APOLLON assembly a profiled cutting. So we save this edits, and so we close the Logikal profile content center, and it's important you have access, of course, to the imported bar assemblies again. So if you have a new construction, you can use the imported bar assemblies directly in your assembly. So now we will assign the profiles. First, the mullion bar assembly here in our 3D sketch. And with a few clicks, yes, we assign here our mullion bar assemblies. Here to the vertical lines, and we have here in the facade also an edge. So, but this concerns later at the end still another feature that I will show you. So now we can, or APOLLON, create the different mullion bar assemblies, and we can, you can see this also here on the left side in the browser. And yes, so we do the step again with the other profiles, the level 2 transom, and then later a level 3 transom. So here we can cross also the constructions, because APOLLON does not override profiles, but only occupies 3 axis lines here in the model. So you can proceed here very safely and specifically here in this process. So here we have the last 3 axes for the transom, the level 2 transom profile. And now also APOLLON does generate the transom profiles. This takes a moment. And now we're coming to the last type of our bar assemblies we use here in our facade, so the level 3 transom. So I have imported this bar assembly in my webinar preparations, because that would go beyond the time frame. So here we have the profile, and we have here 5 single lines in our 3D sketch, but with the special assign mode here in APOLLON, we can join the single lines to one level 3 transom. So, and APOLLON generate here, of course, also the bar assembly. And here at the corner I have occupied two small pieces with the wrong profile, and therefore it is marked orange because the normal mullion profile cannot accommodate the corner. We need here a profile for a 10-degree corner, so we can delete the small pieces, of course. So here we have a special bar assembly for the corner, and we generate the bar assembly on this vertical axis line. And now we come to the cuttings of our facade. So I changed the visual style for a better view quality, also the reflections. So, and now we can take a look of the results. So, okay, so we zoom here to the edge of the facade construction. And in the past webinars, I have also shown you the APOLLON bar cutting function. So we take this command and pick the bar and the boundary object, and now we can use the different cutting classes. So, and we do here, yes, we added here the cutting type and the distance of the different components of the bar assembly. So, as provided by the Vicona system. So, here also profiled, so the mullion, the transom profile, and of course our cover profile. And now we see here the result. So the special profiled cover profile cutting. And now we would like to cross the facade and want to do the cuttings automatically on the same cutting situations on the whole project or the whole construction here. And by the way, this is also a big benefit of APOLLON, so a big benefit for you. So it's not necessary to create the joints individually, but APOLLON does this automatically for the same cutting situations and does not override other cuttings or joints. So this takes also a moment, and APOLLON generate here the transom mullion cuttings automatically on the whole construction. So, and on the last cutting step, we have the edge, the 60-degree edge of the of this construction, and we also use the bar cutting function, and we will join the edge here with the mid-height cut. And of course, you can also apply the cutting types to the other corner joints. So okay, and you can see APOLLON does not override the other cuttings. So the edges are free of cutting, and APOLLON generate only the transom cuttings of the edge. So, and now we take here a look of the result. So on the left side, we have the special profile cutting of the transom, and then on the right side here, the special profile cutting of the cover profile. And I think it's a great thing. So with a few steps, with a few clicks, you can manage all the cuttings in your construction and generate them automatically. So, and we finish here the isolation of our profile. So let us do a small tour again through our construction before we come to the next features. So we use quick the visibility filter. So it's a great tool to filter the different components in the view, and we would take a look to the cover profiles again. So here we see again the special profile cutting situation with a distance of 1 millimeter, and yes, you can exactly this with all kinds of profiles. So for example, semi-finished profiles in the construction, specially designed profiles for large projects. You can create individual cutting outlines and do the special cuttings. So everything is possible in APOLLON, and you have the maximum control here in your model. The next step is, of course, we need infills in our model. So we open the library and we pick an insulating glass with the configuration of 32 millimeter. And we can pick the different planes here, and APOLLON generate here the. So, and if you ask why the infills has the right size after the creation. So the correct clamping thickness and the insertion into the profiles are defined in the bar assemblies. So with the logical bar assemblies, it's defined automatically because it's system dependent. And if you create own bar assembly, you can assign these parameters directly in the component function of APOLLON if you create a new bar assembly. So also this is possible. So, and now for the last planes, we have to create a sheet metal infill. So we can use here also the parameters in the dialog box. And yes, we do some edits. Change the middle of the infill, and we cross the last planes, and APOLLON generate here in the floor center the last infills. So if you want the possibility to do some details to your infills, so you have the possibility now in our update version. So let's take a look to the next feature. So we use the visibility filter, and we filter our construction only to the infills. So now we have a better view, and we use the command infill details, and we pick the different planes of the infill. So, and we can change the layer. So for example here 11 millimeters minus 3 millimeters, and we would create a full glass corner. So now also this is possible to do some details to the infills, for example here a full glass corner. So, and of course we can apply these details to other infills. So you can determine parameters in such a situation and apply them to different sub-areas of your model. Yeah, now you can see that an entrance door is still missing. Well, then we get one via the Logikal interface. It is possible to create a new element using our APOLLON facade command based on a plane in the model. However, I prepared a door since we are already almost at the end of the presentation. So of course, we will show you individual features in further webinars in a detailed workflow again. So we open the Logikal interface together, and we get access to our Logikal projects. So I have prepared a project, the webinar project for the current version, and I will import this entrance door. So we select the position, and now APOLLON import the entrance door directly in our assembly. So we place the door in the model and assign it into the plane. When a new element is created over a plane, it is placed directly on the plane. So that's a different. So now you can use the command attach logical component. So, and we select our door and the surface. And now we can add the different edges to our plane. And now the door is assigned on the plane. A great advantage for you is to use the elements directly in the APOLLON construction to set further required machining processings, for example mounting parts, substructures or sheet metals. As I mentioned earlier, we're going to show exactly that in an extra webinar, especially about this workflow. Finally, we come to an extension of a command, and that is to align profiles freely or to align them to planes when it is required in your construction. In order to obtain a unified view of the central plane of the facade, we would like to align this mullion on the edge profile with a flexible angle support to the plane of the central plane. This is now quite easy to do. You can open this flyout and then simply select the adjacent plane in which you want to align profile. APOLLON then automatically rotates this profile to the plane, and when changes are made in the axis model, this assignment is further taken into the consideration. And now we have already reached the end of the presentation. Thank you very much for watching. In the next webinars, we will also discuss the transfer of bar assemblies with processing to Logikal and ERPlus, for example, to generate a material requisition. And if you have any questions, please feel free to write us on webinar@cad-plan.com. Have a nice day.